Hello viewers, today I am going to discuss Cannizzaro reaction. Now what are the essential conditions for Cannizzaro reaction? There are two conditions. First, aldehydes which do not have alpha hydrogen atom. So all those aldehydes which do not have alpha hydrogen atom will undergo Cannizzaro reaction. Here I have cited few examples. First, formaldehyde. As you can see here, no alpha carbon is available, so no alpha hydrogen. Benzaldehyde, again no alpha hydrogen. 2,2-dimethyl propanol. As you can see here, this is aldehyde group, so it will get number 1. So 1, 2, 3. At second position, you have 2 methyl groups, so it is 2,2-dimethyl propanol. Now this is the carbonyl group, so this is alpha carbon, and on this alpha carbon, no hydrogen is available. So again, this is the example where no alpha hydrogen atom is present. And this is glyoxylic acid, again no alpha hydrogen atom. So these are the few examples of the aldehydes which do not have alpha hydrogen atom. So this is the first condition. Second condition is a strong basic medium, that is concentrated sodium hydroxide or concentrated potassium hydroxide. So these are the two essential conditions for Cannizzaro reaction. And if you can recollect, it is just opposite to that of the aldol condensation. In aldol condensation, the carbonyl group which is undergoing aldol condensation should have alpha hydrogen atom, and secondly the medium is dilute alkaline or dilute basic medium, while here in case of Cannizzaro reaction you require aldehydes which do not have alpha hydrogen atom and the medium is a strong basic medium, that is concentrated sodium hydroxide or potassium hydroxide. Okay, so all those aldehydes which do not have alpha hydrogen atom, when treated with strong alkali, undergo Cannizzaro reaction, in which one molecule of aldehyde is oxidized and other molecule is reduced. Okay, so two molecules of aldehydes are there. One will get oxidized. Aldehyde on oxidation gives carboxylic acid, and the other molecule is reduced, means aldehyde gets converted into alcohol. So one molecule of acid and one molecule of alcohol is formed. Now let's discuss few examples for this. So this is formaldehyde, two molecules of formaldehyde under concentrated NaOH, that is Cannizzaro reaction. One molecule will get oxidized to acid. Formaldehyde get oxidized to give formic acid, but here as you can see it is a sodium salt. Since the medium is basic, so acid react with base to form salt. So it is sodium formate. Plus another aldehydic molecule will get reduced to alcohol. When reduction takes place, this double bond gets converted into single bond. One hydrogen gets attached to oxygen, one hydrogen gets attached to carbon. So carbon with 3 hydrogens, that is methyl group. This is single bond and OH. So this is nothing but the methanol. So formaldehyde undergo Cannizzaro reaction to give sodium formate and methanol. Another example, this is benzaldehyde. So benzaldehyde undergo Cannizzaro reaction to give this aldehyde into acid, and that too sodium salt since medium is basic. So acid aldehyde, benzaldehyde will give benzoic acid, but since the medium is basic, so it is sodium benzoate. Salt of the benzoic acid is sodium benzoate. And another molecule of benzaldehyde gets oxidized, reduced. So on reduction, it gives CH2OH. So C6H5CH2OH. This C6H5CH2, this group is called benzyl group. So this is benzyl and alcohol is attached to it. So it is benzyl alcohol. Next example, 2,2-dimethyl propanol. So one molecule will get oxidized. So this into acid, and in basic medium acid will exist as salt. So it is sodium salt. Now how to name it? If it is acid, then it is 2,2-dimethyl propanoic acid. But since it is a sodium salt, so the name of the compound will be sodium 2,2-dimethyl propanoate. Okay, and the second molecule will get reduced. So in place of aldehyde, on reduction, it gives alcohol, that is CH2OH. CH2OH. And hence the name of the compound is 2,2-dimethyl propanol. So this is a Cannizzaro reaction for 2,2-dimethyl propanol. Now the next example, glyoxylic acid. Now in the glyoxylic acid, there are two functionalities present in it. One is acidic functionality and another is aldehydic functionality. So the reaction, as you know, concentrated NaOH will give Cannizzaro reaction. So this aldehyde part get oxidized in one molecule and gets reduced in another molecule. So this aldehyde on oxidation gives acid. So this is one COH is already there, one acidic part is already there. This also gives acid. So two COH. So COH is oxalic acid. And in basic medium, oxalic acid exists as COO negative Na positive and COO negative Na positive, that is sodium oxalate. So this is the oxidation. Then reduction. So another molecule will get reduced and this aldehyde part will get converted into CH2OH. So CH2OH and the acidic part, and as the acidic part, medium is basic, will exist as sodium salt. So the name of this compound is sodium glycolate. So these are the few examples of Cannizzaro reaction. Now we'll discuss the mechanism. Okay. So what is the first step? As all of you know that this carbonyl group is electrophilic in nature because of the partial positive charge on the carbon. Carbon is having partial positive charge and oxygen is having partial negative charge, and this is due to difference in the electronegativity, as oxygen is more electronegative than carbon. So electron density is more towards the oxygen and therefore partial positive charge on carbon and partial negative charge on oxygen. So since the carbon is having partial positive charge, that is it is an electrophile, so OH negative, which is a nucleophile, will attack it. So OH negative will attack on the carbon and the pi electrons will be shifted towards the oxygen. So now there is a bond between carbon and OH, then single bond and O with the negative charge. This reaction is fast reaction and you will get CHHOH and O negative. Then the next step. In the next step, this ion formed the negative charge on the oxygen. Oxygen comes back between carbon and oxygen, and therefore this hydrogen goes out as H negative. It will take bond along with it. That means bond means 2 electrons, that means hydride ion. So this H negative goes out as hydride ion, and it from here, from this carbon, it moves to this carbon. Because this is nucleophile, H negative, hydride is a nucleophile. This is electrophilic center. So H negative will attack here and the pi electrons will be shifted towards oxygen. So this is hydride transfer from this carbon to this carbon. Now what will you get? When if this H goes out, then it is HC double bond OOH, that is formic acid. And this H negative, when gets attached to this carbon, it is CHH and H, that is methyl single bond with O negative. This is called methoxide ion. So by the hydride transfer, you will get formic acid and methoxide ion. This is a slow step. And now this is the third and the last step, which is a fast step. It is a proton transfer. As all of you know that the carboxylic acids are strong acids, therefore they will lose proton. From here proton, it will release proton and it will take proton. So from here H positive goes out and it will take H positive. So it is O negative. So this is formate. So sodium formate. If you do the reaction with potassium hydroxide, then you will get potassium formate. Since we are doing the reaction with sodium hydroxide, so we are getting sodium formate. And this part, it will gain H positive and will get converted into methanol. So formaldehyde will get converted into sodium formate and methanol. So this is the mechanism of Cannizzaro reaction. Now cross Cannizzaro reaction. Like cross aldol condensation, cross Cannizzaro reaction can take place between two different aldehydes to give all possible products. That means when two different aldehydes are reacting, then it is cross Cannizzaro reaction. I have taken some example where if one of the aldehyde is formaldehyde, then it exclusively gives sodium formate and the other aldehyde gives corresponding alcohol. That means if you take a mixture of two aldehydes in which one of them is formaldehyde, then what will happen? The formaldehyde will get oxidized to acid and the other aldehyde will get reduced to alcohol. Let's see an example. This is formaldehyde, this is benzaldehyde. So when you carried out the reaction with NaOH, concentrated sodium hydroxide, you will find that formaldehyde will get converted into formic acid and then sodium formate, that is the salt, and the benzaldehyde will get converted into benzyl alcohol. So now we have to find out the reason that why the formaldehyde gets oxidized and benzaldehyde gets reduced. Okay. So this is formaldehyde molecule. This is benzaldehyde molecule, and we have seen that this reaction is due to the electrophilic nature of the carbonyl carbon. This carbon is electrophilic in nature and therefore partial positive charge here, partial negative charge here. So due to the partial positive charge, it is electrophilic carbon. Now out of the two, which carbon is more electrophilic will depend upon the charge, the magnitude of the charge. More is the partial positive charge on the carbon, more stronger will be the electrophilicity of that carbon. Okay. Now out of the two, in this case, in case of benzaldehyde, the carbon having partial positive charge is in conjugation with the benzene ring. So this partial positive charge is in conjugation with the benzene ring means the partial positive charge gets delocalized over benzene ring. Therefore, availability of the charge on this carbon is less as compared to the charges, the positive charge present on this carbon. So when you compare the two carbon, on this carbon, the partial positive charge is much more than the partial positive charge on this carbon. Okay. So since this carbon is having more partial positive charge means it is a stronger electrophile and therefore when the nucleophile has to attack, it will attack at this carbon. Okay. So as you know, what is the first step? The attack of the nucleophile. So the nucleophile will then attack to the carbonyl carbon of formaldehyde. So OH negative will attack here and the pi electrons will be shifted towards oxygen. So this reaction we have already seen. Reaction is fast and you will get this. Okay. Then O negative will come back between oxygen and carbon and this hydrogen goes out as hydride ion and will attack on the another carbonyl carbon. Here in this case it is benzaldehyde. So H negative will attack here and the pi electrons will be shifted towards oxygen. So hydride transfer and what will you get from here? It is HC double bond OOH, that is acid, and here you will get C6H5C, 1H from here, 1H here, CH2 O negative. So C6H5 CH2 O negative and formic acid. What will be the next step? It is the proton transfer. Stronger acid will release proton. This will gain proton. So from here you will get sodium formate and from here you will get benzyl alcohol. So this is cross Cannizzaro reaction. Now I think it is clear to everyone that why the reaction take place at formaldehyde carbonyl carbon. That means, or you can say why the OH negative attacks at carbonyl carbon of the formaldehyde, or why always the formaldehyde gets oxidized to acid and another aldehyde gets reduced to alcohol. So this is the reason for that. Now intramolecular Cannizzaro reaction. Till now we have seen intermolecular Cannizzaro reaction. That means inter and intra. Inter means between two molecules. Intra means within the molecule. So those examples which we have discussed till now, they are intermolecular reaction, Cannizzaro reaction between two different two aldehyde molecule. They can be same or they can be different. As we have seen the reaction between two formaldehydes or reaction between two benzaldehyde, and we have also seen the cross one where the reaction between formaldehyde and benzaldehyde. So now intramolecular Cannizzaro reaction in which the aldehydes which contain two aldehyde groups and do not have alpha hydrogen atoms. So molecule has to satisfy the condition required for Cannizzaro reaction, means it should not have alpha hydrogen atoms, and since it is intramolecular, so both the aldehyde group should be present on the same aldehyde. And then the medium, it should be a strongly basic medium. So this is the example. This is glyoxal. Two aldehyde groups are present, a symmetrical molecule. When you add concentrated sodium hydroxide into it, one part of the aldehyde will get oxidized and another part will get reduced. So one aldehyde will be oxidized to acid and then in the sodium salt, while another aldehyde into alcohol. Here I have oxidized this aldehyde into acid and then in basic medium into sodium salt and this aldehyde into alcohol. So here this is alcohol, this is sodium salt of acid, and the name of this compound is sodium glycolate. Now let's discuss the mechanism. It is a symmetrical molecule, as I told you, so you can show the attack of the nucleophile OH negative on either of the carbonyl carbon. Okay, so O negative will attack here and the pi electrons will be shifting towards the oxygen. So it is OH and O negative. Now, what's the next step? Hydride transfer. Okay, so O negative will come back. The negative charge will come back between carbon and oxygen. This H goes out as hydride ion, and here the hydride ion will be shifting from this carbon to this carbon within the molecule. So H negative will attack on this carbon and the double bond, the pi bond, will be shifting towards the oxygen. So what will you get? Look at the structure. Here you will have double bond. This is OH. Yeah, here it is H, and single bond with O negative. So it is CH2O negative and acid. And what is the next step? Proton transfer. Proton transfer. This acidic is a stronger acid. So it will lose proton. This will gain proton. So within the molecule, the proton will transfer from here to here. So here you will have O negative and here you will have OH. So it is OH here and O negative and a positive here. So it is sodium glycolate. I hope the Cannizzaro reaction, the cross Cannizzaro reaction and intramolecular Cannizzaro reaction is clear to all of you. Thank you for watching.